So my first question is, can you share your experience working with the Indian Army, Navy, and Air Force in training cadets on AI and robotics?
Yes, I'm a trainer of AI and Robotics Club in National Defense Academy. There we are teaching the cadets basics of robotics and AI. For robotics, I have chosen the microcontroller board Arduino Uno, which is an international standard for learning robotics. So cadets are learning electronics, computer hardware, mechanical assembly of a and programming. The Arduino Uno IDE programming is based on C, C++ programming languages. So they learn the basic commands. And it's an awareness program. It's a hobby club. So they learn how a robot works. What are the basic parts of a robot? Like sensor, controller, and actuator. And using different sensors, they are doing 7 to 8 projects or activities like obstacle avoider robot, obstacle follower robot, line follower robot, voice control robot, and mobile phone app control robot using a module. Then light follower and light avoider robot using LDR sensor, etc. I am teaching since July 2017, and every 6 months there is an exhibition, expo. It's called as expo, in which cadets will showcase what they have learned in the hobby club. So they have to make some 4 to 5 projects, and I'm very happy to say that since July 17, every time we are doing 5 projects, and not a single project is repeated. So there is a lot of creativity. So this time we had done a color object sorter robot, then automatic vehicle convoy. Like that, we had done automatic rain protection system project, and also a road level measuring robot using accelerometer, GPS sensors. So it goes on every 6 months, and cadets are learning basic of a robot, basic parts of a robot and programming. So that's how it goes. Next question, please.
Yeah. So how has the STEM education contributed to their skill development to the cadet and Indian Army, Navy? STEM education contribution to their...
Yes. STEM means it is there are 4 components of STEM, 4 subjects, namely science, technology, engineering, and mathematics. So they are learning programming skills, they are learning electronics, and they are learning how to apply that knowledge to solve day-to-day problems in our day-to-day life or their defense life, how to solve different problems and come out with some solutions for the problems. So that is a STEM mindset, we can call it. What is a STEM mindset? To solve our problems in our day-to-day life using the knowledge we have learned in schools or colleges. If that knowledge we are not able to use to solve the problems, then what is the use of that knowledge? So this is a new approach in schools nowadays, that it requires creative thinking. Creative thinking means to analyze the situation and ask questions like why it is happening, how it is happening, and what can we do to solve the problem. Then innovativeness. Innovation means to find out something which is earlier it is not existing. That is innovation. And also we have to make experimentation and lot of trials. So that is to be done by hands. This is not an education like on the blackboard and write in the notebook. It is not.
Right.
It's not the traditional way of education, but it is doing by learning by doing. That's how it goes. Learn through your hands. That is the style. That is the method of STEM education. When we do by hands, we learn it in a better way. So that's what the cadets are doing by their hands and learning to solve day-to-day problems.
Okay, great. So my next question is, as a retired space scientist and electronics engineer, what are some key challenges have you observed in STEM education in India? And how are you addressing all these challenges?
Yes. Um, First of all, I would like to thank you and your company Narayandojo for giving me this opportunity of expressing my views and my opinion about STEM education. Thank you very much. So before I answer this question, I would like to mention some examples, some stories of ordinary common people like you and me who have used their knowledge to solve the problems in the day-to-day life. First example is of raincoat. Raincoat was invented in 1824 by a chemist. He was an ordinary person selling medicines. His name is Macintosh. He was walking in a street and suddenly heavy rain started. So he got fully drenched with water. Then he thought, why not make a waterproof garments, waterproof clothing. Then he started working on that. And he took help of his chemist friend, and he did lot of experiments. And he dissolved coal tar and naphtha, these materials, and he dissolved the natural rubber into that, and he made a liquid solution. This liquid solution was sandwiched between two layers of fabric, ordinary cloth, and that's how the raincoat cloth was made. From this waterproof cloth, he stitched raincoats like ordinary stitching. So this is an example how our knowledge can be used to solve day-to-day problems. Second example is of ball pen. Ball pen was invented in 1920 by a newspaper journalist. He was not a scientist at all, but he used to write by fountain pen, and the ink used to get sprayed, the pen used to get leak, and there will be a lot of stains on the paper and on his clothes. So he got frustrated and he started thinking how to solve this day-to-day problem. So then there was a ballpoint pen available for writing on woods and metals, but that was very costly, and the ink was also very costly. So he used ordinary ink and made it more viscous, more thicker, and it became cheaper solution for this problem. So that's how the ball pen was invented. Another story is of Band-Aid. See, these are very simple things, but they are invented by ordinary common people like you and me. In 1920, a cotton buyer named Earle Dixon of Highland Park in New Jersey, America. He was newly married. This story is very interesting. He was newly married, and his wife used to get her fingers cut while doing the housework. Always she used to get injuries. Then every time he has to go to doctor and do the dressing. So he thought, how can I solve this problem? Because night time no doctor will be available. So what to do? Then he observed what the doctor was doing. Doctor will take a gauge, medical gauge, it's called as, on a cloth there is some medicine is available. So antiseptic medicine. So doctor will put on the wound, and the doctor will put a bandage of cloth, and the dressing will complete. So he made a sticky tape. He used the material called crinoline to stick the tape on the human skin. And he applied the medical gauze on that tape. So that's how the band-aid was invented. This is invented by an ordinary common person. Another example is of Velcro. We know Velcro, it's a fastener, rolling fastener. In 1948, George Mestrel was walking in jungle. He was a worker in an electric company in Switzerland. So what happened is green plant. There is a green plant called as burdock burr. So the small green seeds of that burdock burr plant, they got stuck to his cloth and his dog's fur actually. So it was a problem, and he thought, how it is possible? Why they are sticking to my cloth? Then he studies those seeds of that green plant under a microscope, and then he found that there are a lot of curved tooth are there, and he used this. He learned from nature this idea, and one problem he used to solve another problem, and from that he made a rolling type of fastener, which is used in all medical aids and all that. We know Velcro is very much used. There is another example of a lady. She was a housewife. She was working in kitchen, and the problem she was facing, or everybody was facing, was that lipstick. Lipstick used to get dried up, and it used to get sprayed on the clothes. So she was working in kitchen, and she was experimenting with different types of edible oils, then molten wax, and different color dyes. So with experimentation, she invented a no smear lipstick. No smear lipstick. And that was called as $1 lipstick. Based on that invention, she founded a company. Her name was Harley Bishop. Harley Bishop company was founded for cosmetics, and it became a $1 billion company within few years. So these are the examples. And from electronics, I would like to give one example of picture tube for TV. In our TV, a small dot is there, shining dot. From that shining dot, a line is made. Then second line, third line, like that, it goes down on the screen. This is called as scanning. Scanning picture tube was invented by a farmer working in the farm. His name was, he was working in a farm, and after completing the farm work, he saw backwards and he saw that he has completed a square shape of farm using a single point. So using a single point, he had done the scanning of the farm. So similar idea he used, and he invented our picture tube for TV in 1927. So these are the few stories I would like to mention first, because here they have used the STEM mindset. STEM mindset means using the knowledge to solve day-to-day problems. So in current situation, when we start STEM education in schools, to my knowledge, it started in 2016 in India, when the Atal Tinkering Lab was started. And in the Atal Tinkering Lab, there is a word called as STEM. From that, this word came. So problems are faced for a new method normally. And here, first is the mindset of people involved, like parents or teachers or schools. What they may think that students will not get time to study the regular curriculum, and they may lose some marks actually. So we have to convince these people by discussion and by using advertisements that STEM education is very helpful for the students' future life. Because nowadays companies are also demanding STEM education style of working.
Right.
Apart from the degree, they will see whether what is the problem solving skill of the candidate, how much teamwork he can do, and how much creative thinking he can do. So all these qualities are being demanded by corporate companies while recruiting the people. So STEM education will definitely help students in their future life also. So first problem is the mindset of people involved, and we have to solve it by making discussion and making advertisements on TV and convincing the people. Second problem is being faced as the infrastructure. For STEM education, a good computer is required because their programming skills are to be developed for the students. But what I find that suppose a school, they say we have 20 computers, but they are not 20 computers, they are 20 nodes, 20 monitors are there, keyboard and monitor, and one server is there. Whereas Adult Tinkering Lab has given robotic kits, and robotic kits needs a USB port. So USB port is available only for one computer. So this type of problems are there, and these can be solved by giving standalone machines, standalone computers, or standalone laptop to the schools by the corporate companies under CSR scheme. CSR scheme is there because school may have some funding problem, money will not be available, so corporate companies have to give under CSR scheme funding to the schools. Third problem is being faced as the teacher. What I find that normally in many schools, teachers are given non-teaching work. It is say admin work, and sometimes they are overburdened with this type of work. So they don't get time to do the actual teaching work, and somehow they have to finish the portion. So in addition to that, if this ATL or this STEM education work is given, then they may not get proper time. So schools have to see that teachers are getting proper free time for this STEM education. And also training of teachers. It's called as train the trainer, TTT. They say any education system is as good or as bad as the teachers. If teachers are good, the training will be good. If the teachers are bad, the training will be bad. So teachers should be trained properly, and not only once, but again and again they should be trained for new advances in science. What is the latest in the world in robotics? So regular basis teachers should be trained. These are the problems faced by STEM training.
Yeah, there is more to learn from the many common men. How they invented the different solution from their mindset. Moving forward to my next question. Okay, what were your key takeaways from working with Dr. APJ Abdul Kalam and Dr. Vasantrao Gowariker at Vikram Sarabhai Space Center, and how did those experiences shape your understanding of STEM education?
Okay. I consider myself very lucky to have worked with Honorable former President Bharat Ratna Dr. APJ Abdul Kalam sir and Padma Bhushan Dr. Vasantrao Gowariker sir. I have learned many things from them which are very useful to me, not only in STEM education but in my whole life. First thing I learned from them is they are totally for Make in India thought. Because when they were making rockets, they were designing rockets. Dr. Gowariker was in the chemical engineering field, and Dr. Kalam sir was in the aerodynamics field. But they always thought that we should make all the parts of the rocket in India. And they were Indian to the innermost core. There, when designing the first rocket, SLV-3 rocket, they gave different jobs to outside companies, only in India, only Indian companies. 70 Indian companies were selected, 70 Indian companies were selected to make the SLV-3 rocket, different parts of SLV-3 rocket. Like say, motor of the first stage of the rocket, which is a metal cylinder of 1 meter diameter. It was given to Valchandnagar industry here because they are doing boilers for sugar factories. So this is one example. And they gave opportunity to Indian minds, Indian talent to contribute and to participate in the SLV-3 rocket program. So this was the first thing I learned from them, that be Indian and always give opportunity to Indian products. Second thing I learned from them is, first rocket was a failure, SLV-3 rocket in 79, it was a failure. But the next year, within 1 year, the second flight became a success. So here I learned from them that how to convert failure into success. And I was observing, I was participating, I was very junior and they were very senior. So I was observing that they went to micro level management, and in ISRO there is one FAB, which is called as Failure Analysis Board. So they consider what has gone wrong. There will be analysis of failure, which part has failed, what are the reasons for that, and how can we remove those reasons. So like that they anticipated what can fail in future also. So that's a very important learning I got, that when you are planning something, you have to envisage you have to see what can go wrong. And you have to be ready with the solution for that. We say we must have a plan B, plan C, like that, if something fails. Right. So that I learned from them while doing planning. You have to think what can go wrong and what will be the solution for that. That is the second thing I learned. Third thing I learned from Dr. Kalam sir is the word core competence. Core competence means if you are not expert in some other subject, you have to learn that subject by using self-learning method. That's what I learned. When he was handling the atomic bomb, project in 1998, somebody
Smiling
asked
Buddha.
him. Smiling Buddha was in 1974, Pokhran, but 1998 also okay, that was there.
Okay.
So somebody asked Dr. Kalam sir, you are a missile man, you are expert in rockets. So how are you in this atomic work, atomic explosion work? So he said, I agree with you, my friend, my dear friend, but I have the core competence to learn new things. And he really helped that project. He was the main coordinator of that project, and he made it successful actually. So self-learning method, that is what STEM education has give to students, because when they join a company, they may have to learn new things, new advances. So that time self-learning technique must be used. Dr. Vasantrao Gowariker also, after going to Delhi from Vikram Sarabhai Space Center Trivandrum, he was given the job of monsoon prediction, which is totally new subject than the rocket science. But he also excelled there, and he made Dr. Gowariker monsoon prediction model with 16 parameters, varying parameters, and that monsoon prediction model is being used till now.
Oh,
So these are the things which I learned. Another very important thing is always we have to do world-class work. This came from their guru, Dr. Vikram Sarabhai. Dr. Vikram Sarabhai was the founder of ISRO, Indian Space Research Organization. He always used to say, we shall make world-class rockets and we shall be second to none. So that was a inspiring, motivational sentence for all of us. So that's what I have learned. And when I was teaching STEM type of education to cadets, I have used all these 3-4 takeaways which I have learned from these great people. Because in STEM also, there are so many new advances are available. Every day, every week, you would find that something new has come in the market or something new has come in the science. So that you have to self-learn and excel in that. And you have to do always world-class work. That's why I have selected Arduino Uno as a microcontroller board because it is the international standard. So while teaching STEM education, I used all these 4 takeaways which I have learned from these great people. Okay.
okay. So my next question is, how has the new education policy impacted the promotion of STEM education? Your thoughts on this in Indian schools and society?
New education policy, yes.
Yes.
New education policy is called as NEP 2020 and there is now extension in 2023. This year it has been announced. The major changes, now we have got 10 plus 2 plus 3 format. 10 standard is called as SSC, then 2 years junior college HSC, and then 3 years for graduate. So according to new education policy, it will be 5 plus 3 plus 3 plus 4. So 5 plus 3 plus 3, 11, it will be in school and 4 years will be in college. That's my understanding. Okay. So 1 year we are getting more in schools. So far, when it is in SSC, it is 10th standard. Students are not disturbed during the 9th and 10th standard. Whatever training you have to give them, say STEM education, etc., that we have to give in 6, 7, and 8. This standard. You have to teach robotics up to 8th standard only. 9th and 10th standard, you don't disturb them because they have to prepare for the board exam. So here what will happen is we will get one more year. That is 9th standard also we will get. That is my understanding. And 10th and 11th, we need not disturb them for this additional training like STEM education. So 1 year we are getting more. Secondly, new education policy says code writing is to be started from 6th standard. Computer code writing. It may be simple initially, but then we have to teach them how to write program code on a computer. So code writing is already part of robotics. A robotics program starts with code writing. So this new policy will help STEM education in robotics also and vice versa also. While doing robotics, they will learn according to new policy. That is second aspect. Third point, that in NEP new education policy, they have given stress on critical thinking, innovation, and teamwork. Critical thinking is main thing. So critical thinking is required for solving some problem in day-to-day life. So that training we have to give, schools have to give, which is again part of STEM education. In
Yes.
STEM education, they have to do work by hands and solve some problem in real life. So these are the 3-4 points where new education policy will promote, have impact on STEM education.
Okay. So my next question is, how has your participation in projects like India's first atomic explosion, SLV-3, PARAM supercomputer, and fiber optics campus networking impacted your perspective on the practical of STEM education in real world scenarios?
Okay. In my opinion, STEM education is not something different. It is always there. It is a sarva-vyapi, we can say. It exists everywhere. Even if we don't use the STEM word,
Mhm.
you take example of a farmer. He is using science, soil science, crop science, weather
Yeah.
science. Then he is using technology, new products. What are the new fertilizers available? Engineering he is doing. Engineering means using formulas to come to some numbers. So how much acres land he has and what is the yield per acre, like that, all formulas he is using, and mathematics also he is using. So STEM is being used in a natural way by a farmer. You take example of a housewife, he is working in kitchen, he is using STEM technology. Science, he is using the heat, the temperature, the gas stove, LPG stove, etc. In cooking mean there is a lot of new snacks she has to make. She has to do some calculations. How many people are there for taking lunch and dinner and all that. So STEM is being used by everybody in day-to-day life. So when I was working in defense research, there was a project of first atom bomb in 1974. So there was a lot of instrumentation, measurements were to be done, and there was very high precision, that is in microseconds, where to measure the microseconds, and there were a lot of mathematics. So mathematics, chemistry, and engineering was used in that project, 1974 first atom bomb, atomic explosion. Then in space technology, space lab also, Vikram Sarabhai Space Center. When a rocket goes in space, it uses 23 different branches of science, 23,
Oh.
including chemistry for the fuel, rocket fuel, solid fuel and liquid fuel. Then structural engineering, mechanical engineering, computer hardware, computer software for control and guidance, electronics, then aerodynamics. I don't know all the names of these 23 branches of science, but all the branches, they used to say that you should know everything of something and something of everything. That means suppose I am an electronics engineer, I should know everything of electronics related to the rocket. And I should know something of everything of other branches. So knowing everything of something and something of everything, that was required in working in Vikram Sarabhai Space Center. Then when I came to CDAC in 1988, first Indian supercomputer, PARAM supercomputer. That time I was given a non-technical job of materials management. because earlier I was working as a junior engineer, junior level, grassroots level. So I was in touch with engineering and technical work. But as you go in higher and higher in the management side, you have to deal with administration, you have to deal with non-technical problems. So that was called as techno management. And I knew all the parts, all the technical details of the parts of the supercomputer. So I was given the job of materials management in stores. So there also I had to planning was more important, and doing planning we have to use mathematics, science, market, and the technical advances, what is latest available in the world, in the market today. So all these aspects we have to use. So that is again STEM technology only, STEM mindset, I say, STEM mindset. And then we got a project from Gurudev Rabindranath Tagore's Shantiniketan Vishwa Bharati University of doing the fiber optic computer network. So we went there total 5 times, and using the same planning method, I was again in the admin side. It is techno administration. Fiber optic cable was used, and the length of the total network was 13 kilometers. That was the first of its kind in India, and it was inaugurated by Indian Prime Minister. So there it was used for library purpose. That means the students and the professor need not have to come to library. They will get the book details at their seat only. So a lot of time was saved. So that fiber optic campus network was a very interesting project. By working in these 4 projects, atomic bomb, then SLV-3 rocket, supercomputer, and fiber optic network, that has enhanced my capabilities in planning stage. Planning is very important. And what I learned is you have to see the complete cycle from beginning to end. And you have to envisage, you have to think about the likely problems. What will be problems at each stage? And you have to steer in such a way that the problems are avoided, or if the problems they come, you have got a solution ready for that. So lot of time is saved, and lot of money is also saved in that. So this is also part of STEM education, that you have to think of the problems, future problems. So that is my answer to your question.
Okay, so come to the next question. Can you share your insights on the role of artificial intelligence in shaping the future of STEM education?
Yes. Artificial intelligence has got many components like machine learning and natural language processing, neural network, computer vision, etc. So in machine learning, machine will see the pattern, process the data, and learn what is the pattern from that data. And based on that, machine will identify some objects or some faces, human face also it can identify. Self-learning. So this method of artificial intelligence can be used in STEM education for making personalized tutorials for the students. As we know, there are 4 types of learning styles. One is visual learning, second is auditory, that means by listening, Third is reading and writing method. And fourth is kinesthetic. That means doing by hands. So these are the four styles of a learning styles of students. Each student may have different learning style. Nowadays, what is happening is same method is used for all the students, and each student may have a different learning style. So he may not learn properly 100% from one uniform tutorial. But using AI, we can make personalized tutorials. For example, suppose a student has got visual learning style. That means by seeing he understands better. So the AI model can teach him giving more videos, more photographs. So he will understand in a better way. Another student is having say auditory learning style. That means he understands better by listening. Whatever the teacher tells, he understands properly. So based on his learning style, the AI model will give him a lesson which is having more commentary, like that, more speech. So text based or practical based. This type of personalized training can be made by AI, using AI. That is one use of AI in STEM education. Second use is NLP, means natural language processing. Using AI, we can make translator robots for one sentence based. And we can use that regional language translation in our rural areas. Because in rural areas, all the students may not understand English properly. 7th standard, 8th standard students. So there, suppose I have to teach robotics, what I will do is, the main technical words will be same, like microcontroller board, Arduino, then jumper wire, etc. They will be same. But the sentences will be in regional language, like say Hindi or Marathi, like that. So India has got so many regional languages. So if we use AI to translate these tutorials into regional languages, STEM education will be better. Understanding will be better. So these are the two methods where AI can be used. Third is assessment of students. After the STEM training is complete, you have to make assessment. It may not be exam, but some sort of assessment is required and some grading is required. How much the student has learned. There also we can use AI to make different quizzes, different questions, and different projects it can give to students to make assessment of how much they have learned. So these points AI can help.
Okay. So how do you see the integration of robotics and mobile robotics into STEM education, benefiting students in terms of skill development and their career prospects?
Yes. Robotics and mobile robotics, they are very closely related to STEM education. Because STEM education means, as I said earlier, solving real life problems using the knowledge we have learned. Now in robotics, the program is to be uploaded from the computer screen to Arduino Uno memory. So from the computer screen, something is coming out in the real world. You can see the fun. Normally, when I do some programming on the computer screen and I get some result, but that remains on the computer screen. It doesn't come out of the computer. Whereas in robotics, it comes out of the computer and it is given to Arduino Uno microcontroller board, the robotics microcontroller board, which will take some decision and do some action, like say switching on a relay, switching on some electric device, and do some useful work. So that is the robotics, which will give solution to the real life problem. So that's how robotics will help STEM education. Coming to mobile robotics. Mobile means mobile robotics. In mobile robotics, there is a robocar normally, and that keeps on moving. So anything moving requires electric power, that's in the form of a battery, rechargeable battery. So in real life, when we move say traffic problem solutions, or say in a house there is a cleaning is to be done, so things have to move and make the solution possible. So mobile robotics will give help in doing this same education for the problems where movement is required. Now Tata company has come out with a truck which will stop automatically if there is in front of it there is an obstacle, there is a vehicle is there, suppose. So it will stop automatically. So that will avoid the accidents or the collisions on highways. So this type of solution available by using robotics. Okay.
So now, what advice would you give to educators, parents, and policymakers who are working towards promoting STEM education in India?
STEM education in India has started in last few years, 2016 we can say. So 6-7 years have passed, and it has reached to few students. I would say few lakhs of students it has reached. But it has to go further deep into villages. Some steps are required. First is, as I said earlier, mindset of people. It should be made a passion, especially parents. If they believe that STEM education is very useful for their child, then they will start demanding more from the schools. So parents should be told, just like say for example, a girl has to learn Bharatanatyam. Parents think that their daughter should know Bharatanatyam. It's an hobby. Or every child should learn cycling. Every child should know swimming. Similarly, parents should think that every child should learn STEM education. It is going to help the child throughout the life. So that is a mindset we must change, and it can be done by using TV advertisements and newspaper advertisements, discussions like that. Secondly, it may be repetition, but teachers should be given more free time to do STEM education in their schools, and they should be trained regularly. Twice in a year they should be trained, and feedback and survey should be taken from the teachers. what are the problems they are facing, and whether they want any further training in some particular module. Same training has some say 5-6 modules are there. So every teacher may not be expert in each module. So different teachers will have problems in different modules. So there should be training based on the feedback and survey taken from the teachers. That is second thing. Third thing is regional language should be incorporated in STEM training. I'll give you an example. Suppose we make Arduino IDE program. In that IDE program, there is line comments are there. Using double slash, we say what this command will do. It will take Robocar forward. So there, I had typed already. I used it. I will say Robocar आगे जाएगी in Hindi.
Yes.
Marathi or any other language, Malayalam, Tamil. Technology is available. We have fonts in the word and all that. So if we do that, if we incorporate regional language, and while teaching also, we have to teach in regional language because the understanding is better. First, students have to understand the robotics. Then they can learn, and then they can recall. Then they can use it to solve the problem. But if understanding is not correct, then there will be problems in using that. So my suggestion is that we can use regional language to teach robotics and STEM education. One more thing is I searched all the internet, but there is no forum for STEM teachers in India. So there has to be a forum. Forum means it's a internet website where all the teachers can become members and they can share their problems and they can share their experience. They can share their new ideas. Forum is there for Japanese teachers. Forum is there for American teachers. But for Indian STEM teachers, I didn't find any forum. So a forum must be made where all teachers can contribute their posts by internet.
Okay.
Yes, that's all.
Yeah. So what role do you think STEM education plays in the implementation of the new education policy in India?
Okay. New education policy and STEM, they are complementary to each other. That means what STEM education is doing, it will be helpful to new education policy. And what new education is doing, it will be helpful to STEM education. For example, creative thinking. That is the requirement of new education policy. STEM education can do that. There are different kits, STEM training kits are available. By using STEM training kits, creative thinking can be taught to students right from the childhood. Second is code writing is compulsory. Code writing is mentioned in new education policy from 6th standard. So in STEM training also, this is there, code writing is there. Then innovation. Innovation is finding new ways to solve some real life problem. So innovation is also there in the new education policy, and that can be already it is included in STEM education. So all these 3-4 aspects of new education policy can be done by using STEM education. Yes.
Okay, sir. So thank you so much, sir, for delivering such an outstanding discussion. And I am confident that the knowledge and insights that the young mind gained from the session will be valuable for their career development and critical thinking also. So once again, thank you so much.
Yes, thank you very much. Thank you.
Yeah, thank you so much. Yeah.
Mm.